Hello to you all. Welcome to another session here at Mathematics Resource Center. And today we're just looking at one question here. And this is a CSEC past paper question, May 2017. And this part of the question deals with sector of a circle. So we have looked at one aspect of this question already, and I'll scroll on to that shortly, just to refresh you on what we did before. And we're looking at the first part of this question. All right, so we looked at this question previously, and I will add the link to this one in the description below shortly after the live, and you can go and look at the solution for this one. So for today, we are now going to be doing the first part, which is the area of sector. So it deals with the area of sector and per meter of sector. So I give you 2 minutes just to read through the question for yourself and think of the strategies that you would use to solve the question. So which formula do I need, and what do I need to solve this question? So I give you 2 minutes to do that, and then we go through the solution. All right. Okay, so that's about 2 minutes. Welcome, Johnny. Happy to have you, darling, joining with us. Okay, so now that I've given you the opportunity to read through the question, we're going to go ahead and solve the question. Okay, so the first thing it says, in this problem, take pi to be 22/7. So we know that sometimes we use pi as 3.14 or 3.142, but in this question, they're asking you to use pi as 22/7. The next part of the question says, the diagram below, not drawn to scale, shows a field in the shape of a sector of a circle with center O and diameter 28 meters. Angle POZ is 90 degrees. All right, so some key information we have been given. One, we know what we're using as phi. Two, we know that we're looking at a sector of a circle. Three, we know the diameter is 28 meters. And 4, we know that the angle POZ is 90 degrees. So these are 4 critical information, very important information, right? And what we're going to go ahead and do now is to answer the first question, which is 1, calculate the area of the field. So we're asked to calculate the area of this field. Johnny, For me to calculate the area of the field, what formula would I use? All right.
Miss,
So first, okay, go ahead, Dejani.
Miss, would it be 28 over 360 times pi r square?
All right. So tell me the formula. Tell me the formula first. So the area would be, I heard you mention pi r square. And what's the next part? Times,
Miss, something over 360.
okay, something over 360. So we're going to write that symbol, which is theta over 360. All right, well done, Johnny. All right, so well done. All right, so that's the formula for finding area of a sector. All right, and we're going to go ahead and fill this in. So area equal pi, which is 22 over 7, good, times R. R stands for radius. Up here, we are given the diameter to be 28 meters. So we're given the diameter to be 28 meters. So if the diameter is 28, what is the radius? The diameter is 28 meters.
14, Miss.
What is the radius? It is 14. All right, so that's 14 meters. So it's 22 over 7 times 14. It says 14 square, so it's 14 times 14. See if we get that a bit better. So it's 14 times 14 times, what value will we use for theta? Theta stands for what?
The angle.
The angle, good. And what's the angle for this sector? What's the angle here?
90.
Yes, it's 90. Well done. So it's 90 all over
360.
360. Nice. All right. So we're going to go ahead and we can put all of this in the calculator. If you feel as if you want to simplify before multiplying out, you can simplify 2, as we have 7 into 7, 1, and 7 to 14, 2. All right. And then we can also simplify our, let's see if we use another color for the cancellation. So we could simplify the 7 to 7, 1, and the 7 to 14, 2. And the 90 and the 360, we could have simplified that. So that's a quarter. 19 to 91, 19 to 364. And we could even simplify further with the 4, 4 into 4, 1. Well, 2 into 4, 2, 2 into 22, 11, and 2 into 2, 1, and 2 into 14, 2. So we could have simplified. But from my opinion, just going ahead straight to your calculator would save you time. And it's important for you to save time in the exam. So going through and canceling would be good, as you would have smaller numbers to work with, but just going straight ahead into the calculation would save you time. All right, so we would have had 11 times 2 times 2, which gives us, oh, I think I made a mistake here. 7 into 2 into 14 goes 7, good. So it would have been 11 times 7 times 2, which gives us 154. All right, so that's 154 meters square. All right, but we could have just gone straight ahead into the calculation without canceling, and that is my opinion. Go straight ahead. You have the calculator to your advantage. Use the calculator, go straight ahead into the calculation without canceling. All right, so use that to your advantage. Any question? All right. Any question here? Is it clear as to how we find the area of the sector? All right. So not so clear. All right. So we're gonna go through the question again one more time, go through the solution again, and hopefully this time it would be a bit clearer for you. All right. So start from the question. All right. And so go one more time. So in this problem, we're using pi as 22/7. Good. And we're looking at sector of a circle. And they gave us the diameter is 28 meters. And the angle of POZ is 90 degrees. So this is a part of a circle, not the entire circle, but just a part of the circle, right? So they have taken out a part of the circle, and that is the part that we'll be finding the area of for the first question, all right? So in doing that, the first thing that we need to write down is the formula for finding area of a sector. Even if you just write down the formula for finding area of a circle first, and then bear in mind that you're not doing the entire circle, you're just doing part of the circle, and then write down the degrees of what is given over 360 would be the same thing. All right. So the first thing I want you to remember is the formula for finding area of a circle. What's the formula for finding area of a circle? Anyone can answer? The formula for finding area of a circle? All right, so it's in the chat earlier. All right, so Gabriel gave it there. So it is pi r square. All right, so area equal pi r square. Good. So as for the big circle, we're not looking at the entire circle this time. We're just looking at part of the circle. So it's pi r square. And since we're just looking at part of the circle, we add to it times that fraction that we're looking at. And that fraction, we represent it as theta over 360. And theta would be the angle. In this case, it's 90 degrees. All right. So if it was half of a circle, it would still write theta over 360, but theta in that case would have been 180. If it was 60 degrees, we'd put 60 over 360. So whatever the angle is, we're going to put it over 360. So we'll go ahead and we'll fill in the information that we know. What value are we using for pi? 22/7. Good. Now they say r square. R square means radius times radius, or r square in general means r times r. But in this case, the r represents radius. So we're going to have radius times radius, right? And they did not give us the radius, they gave us the diameter. And they say that the diameter is 28 meters. So if the diameter is 28 meters, what is the radius? If the diameter is 28, what is the radius? What do I know about the connection between diameter and radius?
The radius is half of the diameter.
All right, good. The radius is half of the diameter. So if the diameter is 28, then the radius is?
14.
The radius is 14. Well done. All right, so the radius is 14 meters. All right, yes, Gabriel, well done. All right, and thank you, Kim. All right, so the radius is 14. So we're going to go 22/7 times 14 times 14, because r square means r times r. It's 14 times 14 times theta now. The value for theta, 90 degrees. So go ahead and write down our 90, divide by over 360. All right, so we go ahead and we put all of this into the calculator. You could simplify, you could do your canceling to simplify the numbers, but I think you'd go faster if you put everything into the calculator. So I'm going to multiply 22 times 14 times 14 times 90. And then I just press divide by 360, divide by 7. And that gives me 154 meters square, or square meters. And this is the area. All right. So you know that when we're looking at area, it is square. Hope this explanation was me going over it makes it a bit clearer for you. All right. I give you a minute to copy and then go to the next question. All right. So this question has two parts, part 1 and part 2. Roman numeral 1, Roman numeral 2. So we'll finish the first part, which is 2 marks, and we're going to go to the next part, which is 3 marks. All right, so now we're going to go down to the next part of the question. And the next part of the question says the perimeter of the field. All right, we're looking at the perimeter of the field. And coming back to the field, let's look at it. Perimeter. Anyone remember what perimeter is? Anyone remember? Right? So perimeter is a total distance around a figure. Total distance. So we're adding all the distance around, all right? So we're going to add this side here, and this side there. So let's look at the first part. What's the length from O to Z? O to Z would be the what? What of the circle? What aspect of the circle is O to Z? Is it the diameter? Is it a card? Is it a radius? What is it? Anyone? No?
Radius.
Yes, it is the radius. Thank you, darling. All right, so O to Z is the radius, right? And what is the length of the radius that we calculated earlier?
14.
Right, good. So it's 14. So here's 14 centimeters, not centimeters, but 14 meters. And OP, what is OP?
The angle.
So when I said OP, I was referring to this part. That line. So check again for me, darling. Is there any difference between OP and OZ? All right, so I got an answer in the chat. So it's the radius. All right, so OP is the radius just as OZ is the radius. Both of them is the radius. All right, so that's 14 meters as well. So we know the length of two sides. We know this OP and we know OZ. So we're interested in finding now the length of PZ. And after finding the length of PZ, then we'll be able to add all the distances. All right. So PZ, what do we call PZ? Or in other words, PZ is a part of the circle. What do we call this part of the circle? Going around. Going around the circle, what do we call that?
Circumference.
Yes, all right, good. It says a circumference. So PZ is a part of the circumference. So if we're going to find the length of PZ, then we're going to use a circumference formula to find that. All right, so we're going to use the circumference formula. So we want to find PZ. So let's write down the formula for circumference. Yes, Gabriel, so it's the arc, and yes, Stacy, it's a circumference. All right, good. So what's the formula for finding circumference of a circle?
Pi d.
Pi d. All right, so we'll go with pi d. All right, and looking at this, is there any other formula? So pi d is correct. Well done to Johnny. So is there any other formula? All right, so it's pi d, or we could use 2 pi r square. Not 2 pi r square, but 2 pi r. All right, so it's pi d or 2 pi r, not 2 pi r square, but 2 pi r. All right, looking at this diagram that we have, is it the entire circle that we're finding the circumference of? Is it the entire circle going around that we're finding the circumference of?
No, ma'am.
No. All right, so it's part of the circle. All right, so as we calculate the circumference for that part, we need to now multiply this by what fraction of the circle we're looking at. So I'm going to multiply by theta over 360. All right, so since I'm not finding the entire circle, we're not finding the circumference of the entire circle. We're just finding a part of that circumference, just a part. So we're just looking at a part of the circumference, not the entire circumference. So we need to multiply by theta over 360. So I hope you understand how and when we use theta over 360. All right, so we use theta over 360 only when we're looking at a sector of the circle. We're looking at part of the circle, whether it might be we're looking at the area or we're looking at the circumference. All right, so we'll go ahead and write our C equal, what's the value of our pi? What did they say we should use pi as?
22/7.
22/7. Well done. All right, so write our 22/7 times what does D stands for? What does D stands for?
Miss, what's the question?
What does D stands for? So we're filling in. So we have pi, we have, yes, it stands for the diameter, Gabriel. So we have 22/7 times D. So what does D stands for? What we're going to put in there? So Gabriel says D stands for the diameter. What's the value of the diameter?
28.
28. All right, good. So we put in our 28 times, what's the next thing we're multiplying now? So we're filling out pi, we're filling out diameter. What's the next thing we're going to put in?
360.
All right, so it's theta over 360. What's the value of theta?
90.
It's 90. All right, so the value is the angle. So it's 90. Good. So it's 90 over 360. All right, so go ahead, we put this into a calculator. And that's 22 times 28 times 90 divide by 360 divide by 7. And that gives me 22 meters. All right, am I finished?
No, Miss.
Okay. What did the question ask us to do?
Find the perimeter field.
Find the perimeter of the field. And this 22 that I've found is for the arc here, 22 meters, right? See if we erase that line and just fill that in. So it's 22 meters. All right. So now I need to find the perimeter. What am I going to do to find the perimeter?
Add all around.
Add all around. Well done. Well done, darling. So I'm going to do the perimeter and I'm going to add my 22 meters, which is for the arc, right? PZ. And I'm going to add the length for PO and the length for OZ. All right. So add those lengths. So that's my 14 plus my 14 meters. And what do I get when I add these up?
50.
50 meters. And there goes the perimeter of the field. And that's it. So this question in total value 5 marks. To be honest, I don't think you would get 5 marks for this question. So this was 2017. I'm not sure if they're still giving 3 marks for this because each year the marks are reduced, in my opinion. But this question value 3 marks. 3 here and 2 there, so 5 marks. All right, so go ahead and write down the solution. As you write down the solution, I'll just mention the skills that you'd need to solve this question again. So 1, you need to know the parts of a circle, right? So you need to understand what a sector is. You need to know how to identify the radius. You need to know that the radius is half the diameter or the diameter is twice the radius. So if the radius is 4, then the diameter is 8. If the diameter is 12, then the radius is 6. If the diameter is 7, then the radius is 3.5. So you need to know that the diameter is twice the radius or the radius is half of the diameter. Okay. You also need to know the area of a circle, right? I need to know how to find the area of a sector. Should be able to identify the angle that you're looking at for the sector. So we're able to identify the angle up here, to be 90 degrees, right? So should be able to identify that. And then from that, you're able to find the area of the sector. Next thing that you need to know to do is to find the circumference of a circle and the length of an arc. All right. And finding the length of the arc is basically multiplying the circumference by whatever angle the arc occupies. All right. And the next thing is finding the perimeter of a sector, which is adding all the lengths. Adding the length of the arc, adding the length of the radius, and there you would have the perimeter of the sector. So that's it for today. We actually on time with our time, so it's has been 31 minutes now, and it was a pleasure being here with you again at Mathematics Resource Center doing this CSEC question on measurement, May 2017. And as mentioned earlier in the video, we had completed this part of the question. So I'll add the link to this part. So we completed this part before, which is the next part, measurement part to this question. And you can go ahead and go through this video and learn how to solve this question. All right. For mathematics, it is not just about learning the skills, it's more about practicing what you have learned. So you go back and you look at this question, you write it out, and you try to do it on your own and go back to the solution to see if what you have done is actually what the solution should be, right? So it's all about practice, practice, practice. All right, until next time. Have a good day. Bye-bye.